Hello, I'm Professor Rad, and this is Precalc video 316, double angle formulas. So in our last video, we talked about new types of formulas for trig functions. Those were the sum and difference formulas. In this video, we're going to be talking about double angle formulas. As with the last video, we'll also be talking about some examples that we can use to, examples of applying these formulas and to help us try to remember them. So what's one thing that's weird about the double angle formulas is that we have one double angle formula for sine. So sine of 2 theta is 2 sine theta cos theta. And we have one double angle formula for tangent. So we have tangent of 2 theta is 2 tan theta over 1 minus tan squared theta. For cosine, we have 3. So we have 3 double angle formulas for cosine. And the one that you're going to use is really going to depend on your personal preference and what information you have available to you. So cosine of 2 theta is cos squared theta minus sine squared theta. So this is helpful if you know both sine and cosine. Be careful, this is not the Pythagorean identity because it's subtracting and not adding. But if you use the Pythagorean identity, you can rewrite cos squared theta as 1 minus sine squared theta, and that's how we get this equivalence of 1 minus 2 sine squared theta. You can also use the Pythagorean identity to rewrite it as 2 cos squared theta minus 1. So these two here are useful if you know information about just sine or just cosine. So you can kind of get away without having to find the other one. So I'll be honest, I have trouble memorizing stuff. And these just don't fit any nice patterns for me. So it's hard for me to memorize them. So what I do, this is maybe bad as a teacher, but what I do is when I see sine of 2 theta, if I can't remember the formula offhand, I'm going to think of that as sine of theta plus theta, right? Because theta plus theta is 2 theta. And I can remember my sum formula for sine because I had a little trick. So the formula for sine was sine, cosine. So I could rewrite this as sine of theta plus theta as sine theta cos theta, sine theta cos theta, same. And now I have sine theta cos theta plus sine theta cos theta, which gives me 2 sine theta cos theta, which is what the formula says. So the double angle formulas can be derived by using a sum formula for either sine. And if you did the sum formula for cosine, you would get the same result here, right? Think about cosine sum formula. So the sum formula for cosine is cos, cosine, sine opposite. So if I have cosine of theta plus theta, it's going to be cos theta, which is cosine squared theta, sine theta, which is going to be sine squared theta, and then opposite. So the opposite of plus would be minus. And then if you wanted to get real fancy for tangent, you could use the quotient identity as well. So if you have trouble, the easiest thing is to memorize these. But if you have trouble memorizing them, you can derive them from the sum and difference formulas. So if you're only have the bandwidth for one set of formulas, sum and difference, those are the ones to remember. And the Pythagorean identity, because that helps all the time. So yeah, so now that we have these formulas, let's do a couple of examples of applying them. And if you haven't already, you can pause the video here and copy these down in your trig review sheet if you wish. I think they're also on page 2. All right, let's do an example. For our first example, we have that sine of phi is 4/5, and we know that phi is in quadrant 1, and we'd like to find cosine of 2 phi. Now, one thing I want to point out about a double angle formula is that the argument of the double angle formula is different than the argument of the functions that we use to find it. What I mean by that is here we have cosine of twice phi, and here we have sine of just phi. So we don't have the same angle inside both of those trig functions. You might want to bear that in mind. Now, for the cosine double angle formula, we have a menu to choose from. So because we only know sine of phi and I don't want to have to go through the trouble of finding cosine of phi, possibly make lots of mistakes, I'm going to use the second one here. So the second formula only depends on sine of the angle, so we can use that to find cosine of twice the angle. So cosine of 2 phi is going to be 1 minus 2 sine squared phi. So this is 1 minus 2 times sine of phi is 4/5. We're going to square that. So we have 1 minus 2 times 16 over 25. 16 times 2 is 32. So this is going to give us a negative 7 over 25. Yeah. So there we go. So cosine of 2 phi is going to be negative 7/25. Now, you might be wondering, Professor Ed, phi is in quadrant 1, and in quadrant 1, sine and cosine are both positive. So how are we getting a negative answer for cosine of 2 phi? How does that work? So remember, the arguments aren't the same. So if I look at where phi is going to live, so let's see. Actually, this is a 3, 4, 5 triangle, right? So I can tell that the coordinates for phi are going to be at 3, 4. So this is our angle phi. If I double that, it's going to move me into the second quadrant where cosine is negative. So this bigger angle, that's 2 phi. So it's possible for the double angle to be in a different quadrant. It doesn't have to be though. Like if phi was really tiny, right? So if phi is this tiny angle here, and I double it, I'm going to stay in the same quadrant. So it's really just going to depend on how big the angle is, whether when you double it, you're going to end up in the same quadrant or a different one. So just kind of keep that on your radar. Just because phi was in quadrant 1 doesn't mean that the double angle formula is going to result in a positive value. All right, let's do a second example. And this time, let's make it a little bit more complicated. For our second example, we're going to find cotangent of 2 alpha when alpha is the angle that runs through the point -3, -11. Okay, so one of the things that makes this one a little bit trickier is that we're looking for cotangent of 2 alpha, and we don't have a cotangent listed as one of the formulas. So we're going to have to get crafty and use some of our other identities to help us out. For example, I could use a quotient identity, and I could do cotangent of 2 alpha, or sorry, could do cosine of 2 alpha over sine of 2 alpha. So then I would use one of these formulas for cosine of 2 alpha, and then I would use this one to find sine of 2 alpha. And then I could use the quotient identity to figure out cotangent of 2 alpha. But that's a lot of work. It's a lot easier to take the reciprocal here because tangent and cotangent are reciprocals. So if I take the reciprocal of this expression, that will give me a formula for cotangent of a double angle. So let's do that. So we have tangent of 2 alpha is going to be 2 tan alpha over 1 minus tan squared alpha. So if I take the reciprocal of the left, I'm going to get cotangent of 2 alpha. And if I take the reciprocal of the right, I'm going to get 1 minus tan squared alpha over 2 tan alpha. So now all we need to do is figure out what is tangent, and then we can plug it in and get our value. So the good news is for tangent, you need to know the x and the y values, because tangent of an angle is going to be y over x. Since we know the point that alpha goes through, we know the x and the y values, so we can just plug those in right here. So we're going to get negative 11 over negative 3, or just 11/3. So now we can substitute 11/3 in for tangent of alpha. So we're going to get 1 minus 11/3 squared over 2 times 11/3. That's going to give me 1 minus 121 over 9 over 22 over 3, sorry. So I'm going to go ahead and multiply big numerator and big denominator by 9 to clear out those fractions. So that will give me 9 minus 121 all over 66. 9 minus 121 is going to give me a negative, I'm going to go over here, a negative, is that 112? Yep, I think that's what we get, over 66. Now both of those look like even numbers, so let's divide out a common factor of 2. So we're going to get a negative 56 over 33. So that's what we get for our cotangent of 2 alpha. All right, so that's going to conclude this video for the double angle formulas. So as you can see, sometimes we might want to pick and choose which one to use, and there are pros and cons to all of them. So just use your best judgment and go with what's going to seem reasonable for you. And yeah, in our next video, we're going to look at the half angle formulas. So this will be our 3rd video now of some more complex formulas. And we're not going to derive the half angle formulas, but they could be derived from the double angle formulas, just if you're curious. So I hope this helped you to apply and learn about the double angle formulas. And I hope you have a wonderful day. See you next time.